So rate of change, it's how much, it's basically unit rate. It's how much each thing is changing related to the other. So rate of change, rate of change, how much changed compared between y to x. Now, when you talk about x and y, think about science. Which one of these do you control, the x or the y? You control the x. So this is like the amount you bought. So this is the quantity purchased something. This is usually cost, or it's going to be. So like this is the quantity. This is output. Cost, input is x. We put in x, we get out y. So I go to the store, I buy 5 Bath & Body Works bulb things. I get out $18. Just smeared it. Alright, then, in 6th grade, y'all covered proportionality? Proportionality. So, proportional relationships. Relationship. A proportional relationship. Proportional relationships have a multiplicative relationship. Multiplicative relationship. And it has a constant rate of change. Constant rate of change. Each thing costs the same. It's a straight line. It doesn't vary. Let's go ahead and add that straight line. No bend. And it goes through 0, 0. Because if I buy 0 things, I spend $0. Make that a semicolon so it doesn't look like it. If I buy 0 things, I spend $0. And then each thing costs the same, so your graph would go straight up. Unless you're at a sale, and it's a buy 5 for 18, and then your graph looks like this, and then it does this. And then it would do this, and then you get another break at your next 8 or 5 or whatever it is. So anytime you have a quantity associated with the cost, it's not proportional. Like soaps at Bath & Body Works, they're like $7 a piece. But if you buy 5, they're $25, which makes them $5 a piece. So again, your graph would go $7, $7, $7, $7, and then it would break and jump down to where they only cost $5 a piece. So it's non-proportional.
So there was 49.
Yes. You save a lot of money. Shop sales. It's important. So a proportion. Don't pay full price.
Just go to your outlet.
A proportion is 2 ratios that are equal. Remember, it looked like this. Proportion was this thing. 1 fraction equals another fraction. So like 2/3 and 36 and x. That kind of situation. And last vocabulary word, it's a lot of vocabulary. Constant of proportionality. Constant of proportionality. This is a formula. K equals y over x. K equals y over x. Now, these are the same. Which is also, if I buy 5 things for $15, how much was each thing?
$3.
$3. So my unit rate is 3. That's also my constant of proportionality. It's also my rate of change. All of those things are unit rate. So this is the same as this, and they are both unit rate. So if it asks you for the constant of proportionality, it's just asking you how much is one thing, how much is it going up each time. If it asks you for rate of change, it's asking you how much does it change each time. If it asks you for unit rate, it's asking you how much is each one thing. It all means the same. Why we choose to teach it this way, write your senators and ask them. Because I didn't get to decide this. All right. TEA is always looking for input. All right, next thing. Because you're pre-AP, we'll go here. No, there's more. We're squeezing a lot into one lesson today. So, but it's not difficult. I don't know. It's just a lot of vocabulary. Yeah. So like it can be said a lot of different ways, but the math is the same over and over and over. So this and this and this can also be this. This is the big one. This is the one that you will actually use outside of 7th grade.
Illuminati. Oh my gosh.
It's not geometry.
Not the Illuminati either.
This is delta. This is delta y over delta x. These are Greek symbols, not a triangle.
Aren't they supposed to be like translated for Illuminati?
No.
Aren't they letters?
They're Greek letters, yes. These mean change. So we would say this change in y. Change in y over change in x. Change in x. And which one of them is independent? X or y?
X.
X. So we have dependent over independent. Dependent. Independent. We haven't done any math yet. I just want to say that. This has all just been verbiage. This beautiful thing right here, we will come to call slope at some point, but not today. It is the constant y over x. Y over x. If you go up to the top, rate of change is also y divided by x. The unit rate, we do y divided by x. How much did it cost divided by how many things did I buy? Yes.
And so like for the proportion to ratios that are equal to x and over 36 is then 36 over the y and the x is over y.
Well, this x, I just use x as my variable. It's really the y. That's where things get kind of fuzzy. I always use x as my variable because it just is. I don't know why. Why? Alright, so you might see it as a table. I'm going to move this down. I know. If you need to write on the left side, do. So, my table. My beautiful ratio table. When you are in science, do y'all have a rule about which one goes on top versus bottom with x and y?
No.
Your x variable, y variable? Yes, you do. X goes on top, y goes on bottom. When you graph an experiment, what you choose, what you can't, like what you control, goes on top, and then what happened goes on bottom. Like you can control with what time you check, like if you grow the little bean and the little paper towel that everybody does at every point in their life. You didn't put the little bean in the wet paper towel in the baggie and hang it on the window and watch it grow?
No.
Oh, you've been deprived. I'm sorry.
We just did the baggie with the bean.
Yeah. So you get to decide when to check the bag, and then how tall it grows is not up to you. You don't get to decide how tall your little bean sprout grew. You determined what times, so that's your X. For me, it's going to be pounds, because I can determine I'm going to the grocery store, I need to buy hamburger meat. I can determine the pounds. I cannot determine the money. I can buy a pound of hamburger meat. I can anticipate how much money it's going to cost, but I don't get to say, I'm going to buy a pound of meat for $1. No. Also, don't eat that meat. That's probably not good meat. So, 1 pound, 2 pounds, 3 pounds, and let's go 6 pounds, just to throw a wrench in this thing. Because y'all are smarty pantses. Alright, down here. If 1 pound costs $4, 2 pounds would be 3 pounds would be 6 pounds would be
24.
That is this is it. If you could fill out this table, that's it. That is a rate of change. It is a proportional relationship because each one of these is equal. They're equal ratios. There is a constant of proportionality because 24 divided by 6 is 4. 12 divided by 3 is 8 divided by 2 is, and 4 divided by 1 is. That's it. It's a proportion. That is your constant rate of change. Y divided by X. Up here. Y divided by X. Now, that's basically it. I'm going to stop there.
See you later.